Hey everyone and welcome back to the channel. Suppose you are building an app and you have heard about the Redis. It is the super fast in-memory data store that everyone is talking about. It can speed up your application like crazy. But here is the thing. Redis is incredibly powerful, but it is not a magic bullet. If you jump in without understanding its core concepts, you could be heading for production nightmares, data loss, or performance nightmares. In this video, we are breaking down the 10 critical things you must remember before you use Redis in a production system. So let's get into it. So, number one is the most fundamental. Redis is an in-memory data store. This means that all your data lives primarily in the RAM. This is the secret sauce to its blinding speed, but it comes with three big implications. First is the cost, because RAM is more expensive than disk. A large data set, when stored into a RAM, can get very costly, but it can become very fast, no doubt. Second is the volatility. By default, data is ephemeral. If your server restarts, all your data can be lost. Third is the capacity. Your entire data set must fit in the available memory. You cannot have a 10 GB data set on a 8 GB server. Thus, model your data size and growth. Use the info memory command to monitor usage and always configure persistence if you need your data to survive a restart. This leads us to the next important topic, which is the persistence. It is configurable but not default. This is a huge misconception among the users. People often assume that Redis saves data to disk automatically like a traditional database, but it does not do so. The default configuration has persistence disabled. You have two options to change this. First is the RDB snapshotting. It takes a full snapshot of your data at intervals you set. It is great for backups and fast restarts, but you can lose all data since the last snapshot. Second is the AOF, which means that append only file. It logs every single write command. This is much durable. You can even set it to save after every command, but the log files get larger and restarts are slower. For most use cases, enable at least RDB. If you cannot afford any data loss, use the AOF. Just know that with append fsync always, you trade some performance for the safety. Third is a major performance gotcha, that Redis is a single-threaded beast. For all its core operations, command processing, networking, Redis uses just one thread. This is great for atomicity, but it means that there is no true parallelism. The big danger here is that slow commands are deadly. A single slow command like keys star on a large database or a complex synter command on huge sets will block the entire server. Every other request gets stuck in a queue, hence causing a massive latency spike for all your users. Hence, avoid blocking commands in production. Use the scan command instead of keys, and always be mindful of the time complexity of your commands and use replicas to offload slow read operations. Next thing to keep in mind is that plan your eviction policy. What happens when your Redis instance hits its max memory limit? The answer is that not the same for everyone. The default policy is no eviction, which means that new writes will just start returning errors. You must configure the max memory policy based on your use case. For example, all keys allow you can evict the least recently used keys. It is perfect if you are using Redis purely as a cache, and volatile LRU can only evict keys that have a TTL set, and volatile TTL evict keys with the shortest time to leave first. If it is a cache, use all keys LRU. If it is a mix of cache and permanent data, use the volatile LRU and set TTLs on your cache keys. Next thing to remember is that Redis is not just a simple cache. Its power comes from its advanced data structures. Don't just use it for simple strings. Use hashes to store objects, which is more memory efficient than separate strings. Use lists for queues, timelines, or stacks, and use the sorted sets for leaderboards. It is a killer feature that makes this trivial. Choose the right data structure for the job. It will make your life easier and your app faster. Next is that TTL is your friend, but it also has a cost. Automatic key expiry is fantastic, but remember that Redis reclaims memory from the expired keys lazily and in active bursts. Here is the problem. If you set a million keys with the exact same 24-hour TTL, they will all try to expire at the same time. This creates a signal problem, causing a CPU spike and potential latency. Thus, add jitter to your TTLs instead of the 24-hour TTL. Use the 24-hour plus a random amount of time added into them to spread the expiry over an hour and avoid the thundering herd. Next is the security concern. A fresh Redis install has no password and is open to the world. Hence, this is a recipe for disaster. To ensure the strengthened security, always set a strong password into your Redis DB and use a firewall to restrict access to only your application servers, and rename or disable dangerous commands like flush all and config in production. And if you are on Redis 6.0 plus versions, Use the access control lists for fine-grained user control. Next thing to keep in mind is about the networking and latency. Redis is so fast that the network is often the main bottleneck. Each command has a round trip time, making 100 GET API calls is far slower than one mGet call. The solution is pipelining, which is sending a batch of commands without waiting for each individual reply. This dramatically reduces the effect of latency. Use connection pooling and enable pipelining in your client driver. Batch your operations wherever you can to optimize your application performance. Next thing, to have a disaster recovery plan. A single Redis instance is a single point of failure. Hence, you must keep your plan ready to face the disaster situation and to successfully recover your data out of it. Use the replication, set up replica nodes for the scalability and as a hot standby. Add the automatic failover. Use the Redis Sentinel to automatically manage failover in a simple setup. And for the high availability, use Redis cluster for automatic sharding and high availability across multiple masters. And don't wait for a failure to happen into your app. Plan your architecture for high availability from the start. Next thing to keep in mind is that Redis is not a relational database. Do not try to use it as a direct replacement for PostgreSQL or MySQL because Redis is optimized for a completely different use cases. You can't use a join to join your tables to collect your data is spread across the multiple tables. Redis transactions don't have rollback on failure. If one command in a multi-exec block fails, the others can still run. Your application code is entirely responsible for the data structure. Hence, use the Redis as a complementary and high performance tool in your architecture, specifically for caching, sessions, and real time features. Your source of truth should almost always be a durable, disk based database, for example, PostgreSQL or MySQL, etc. This comes to the end of our video here. The 10 things we discussed here is absolutely uh, a must remember topic to keep in mind before using Redis. Redis is an amazing tool, but like any powerful technology, you have to respect its characteristics. If you found this video helpful, do me a huge favor and hit that like button and subscribe for more content on system design and backend engineering. Thank you so much. Let me know your feedback in the comments. Thanks for watching, and I will see you in the next one.